Hello, this is Mrs. Sargent, and this is lesson 2.4, Radioactivity and Types of Radiation. So what is radioactivity? The stability of a nucleus depends on the proton to neutron ratio. We like them to be very close to each other, so kind of like a 50-50 ratio, but pretty close in numbers. Atoms become unstable if they have too many or too few neutrons. And when those atoms become unstable, their nuclei undergo radioactivity in order to become stable, giving off radiation in the forms of rays and particles. So we are going to talk about those rays and particles today. So the effects of radiation on the human body creates some free radicals with electron emission, and that disrupts the DNA in our cells, and this can cause massive cell death, development of cancer, and development of gene mutations. So alpha radiation emits a helium nucleus. The symbol for this is 4/2 He. So the mass number, atomic number, symbol for helium. You may also see alpha written as an alpha particle like that. So the mass is 4 AMUs. The charge is +2. Penetrating power is low. And it can be shielded by paper or skin. So in order for alpha radiation to occur, there has to be too many neutrons in the atom. So in order to figure out what our unknown is, we need to solve for x. So if you set it up, 204, because that's the mass number for lead, equals under the arrow, x under the blank, plus under the plus, and 4 under the HE. Subtract 4 from both sides to get x by itself. So our new mass number is 200. And we can do the same process for the atomic number. We're going to subtract 2 from both sides, and our new atomic number is 80. And that is mercury. To determine the unstable nuclei, we can do the same thing, solving for x. 222 plus 4 is going to give us a new mass number of 226. And then do the same thing for the atomic number. So our new atomic number is 88. And atomic number 88 is radium. So the rule when going from left to right, the atomic number is going to decrease by 4, and the atomic number is going to decrease by 2. But notice here we have conservation of mass. We have 204 on the left side, we have 204 on the right side. 226 on the left, 226 on the right. The atomic number is changing because the number of protons is changing, which changes the identity of the element. Beta radiation emits electrons. The symbol for electrons is an E with a 0 for the mass number, because we said they're approximately 0, and a -1 for the charge. You may see for beta particles this symbol. The mass is approximately 0 AMUs. The charge is -1. Penetrating power is moderate. And you can shield with metal foil, wood, or glass. So beta radiation occurs when you have too many neutrons. And so we're going to convert a neutron to a proton by emitting an electron. So if you think about the neutral sign that I gave you, and put a plus and a minus. So for it to be neutral, plus and minus have to equal each other. And then we're changing this neutron into a proton. And we're giving off an electron. So in order to find out our unknown, we're going to do the same thing. 66 equals x plus 0. So solving for x, the mass number is going to stay the same. And then to solve for x, we got to subtract a -1 from both sides, which really means we're adding. So our new atomic number is 30, which should be zinc. And then for our last example here, we want our mass number is going to stay the same. But then for the atomic number, 83 plus a -1 is 82. And atomic number 82 is lead. So the rule going left to right is the mass number stays the same. The atomic number is going to increase by 1. And then our last thing that we need to talk about is gamma radiation. This is emitted in electromagnetic waves. Electromagnetic waves include visible light, UV light, microwaves that you use to warm your food up with, and X-rays. So the symbol for this is 0 over 0, and then this curly Q Y. There we go. Sorry, there's been a delay. So the mass is 0 AMUs. There is no charge. Penetrating power is very high. To be able to shield from gamma rays, we need to have lead or concrete. So you may have gone to the hospital before to get a X-ray, and they put on that heavy apron on the other part of your body, and that is a lead apron. Gamma radiation only occurs with alpha and beta radiation. So the mass number stays the same. And the atomic number also stays the same. So those are the 3 different types of radiation that we are going to discuss. One last thing, I have this picture to show you, and it kind of shows you the size and the mass of the particles and what they can penetrate. So the alpha, we said, has a very low penetration power. You can protect yourself from that with skin or paper. Beta radiation is going to pass through that skin or paper, but it is going to hit a wooden wall. And so that is done. And then gamma radiation, the waves move back and forth, and they are finally stopped by concrete. So you have practice in your packet for this lesson. Make sure you take a look at those and stop by and see me if you have any questions. Thanks.